Alright, and welcome back to our second video on acids and bases. In this video, we're actually going to talk about pH and pOH calculations, as well as how to find the concentration of a solution if you know the pH or pOH. You are going to need something to write with. You're going to need something to write on. A calculator would be very helpful for this because we are going to be doing some math. So you can pause the video until you have all of those. Okay, first thing we need to talk about a little bit is water. Water is what's called an amphiprotic or amphoteric substance, meaning that it is both an acid and a base simultaneously. Right, so water is a very weak acid. It's also a very weak base. And we can show this by looking at the reaction of two water molecules. Right, so two water molecules, if they react, we get our normal acid-base reaction. And what winds up happening is that the acid here, so this water molecule will be our acid. This one will be the base. A hydrogen is transferred from the second water molecule over to the first, giving H3O plus and OH minus. Alright, so this shows that water can be both an acid and a base simultaneously. We can also do a little bit of a shorthand with this if we don't want to write out the whole thing. I can, instead of doing two water molecules, just show the ionization of one. And I can say H2O will form H plus and OH minus. Right, so either of these two equations are useful. In fact, what you're going to see throughout this is you're going to see us use H3O and H plus simultaneously. They are pretty much the same thing for our purposes, right? So they're essentially equal. Now the key thing to take away from this is that whenever water either dissociates or reacts with itself, it produces an equal amount of H3O plus and OH minus. That's what makes water neutral, right? Having an equal concentration is what makes water neutral. If a solution has more H3O plus or more H plus in it, it's an acidic solution. If it has more OH minus, it's a basic solution. Right, so determining whether a solution is acidic or basic is looking at the concentrations of the ions involved. More H plus, acidic, more OH minus, basic. If they're the same, it's neutral. Now, one little fun fact that people like to say is that neutral solutions have a pH of 7. That is only true at 25 degrees Celsius. Once you change the temperature, the actual amounts of water that will break up change a little bit, so the actual pH and pOH of a neutral solution will be a little bit different at higher or lower temperatures than 25. Alright, so that is working with water, and now we'll get into some of the math. So the equation for pH is based on a logarithmic function. A logarithm means that a 1 unit change in the answer is a 10 unit change in the initial concentration. Right, so this is the Richter scale is also another commonly used logarithmic scale. Right, the difference between something that is an 8 on the Richter scale versus a 9, the 9 is 10 times more powerful. The difference between a 7 and a 9 is 100 times more powerful than a 7, 1,000 times more powerful than a 6. pH works the same way. Right, so something that has a pH of 1 is 10 times more acidic than something that has a pH of 2, 100 times more acidic than a pH of 3. The equation we're going to look at is the pH is equal to the negative log of H3O plus, or you can say negative log of H plus. I'm not going to ask you to learn how to do math with a logarithm. That's something you cover in Algebra 2. All I'm going to ask you to do is be able to press the button on your calculator properly. Right, so if you have a TI calculator, you're going to use the negative key, you're going to press log, then you're going to put in the concentration, and you press enter, it'll spit out your answer. Right, that's all I'm expecting you to be able to do with this. So pH is negative log of the acid concentration. Similarly, there's an almost identical number that we call pOH. pH is for acid, pOH is for bases. So pOH works off of hydroxide. Same exact equation, just replace H with OH. Right, so we have pH, we have pOH. They're two very similar formulas to each other. You use pH if you're working with an acid. You use pOH if you're working with a base. And the other important thing to keep in mind is that if you add these two numbers together, they always add up to exactly 14. Right, so what that means is that if you know one, you can find the other. Right, so pH plus pOH is 14. These are 3 of the 6 important equations you're going to need for this. The other important equations are how to do the reverse. So the pH equation was if I know the concentration of the acid, I can find its pH. What we also want to be able to do is do the reverse. If I know the pH of the acid, I want to find its concentration. In order to do that, all you're going to do is undo the logarithm. To undo a base 10 logarithm, you take the pH and you do 10 raised to the negative pH, and that gives you the concentration of the acid. 10 raised to the negative pOH gives you the concentration of the base. All right, so this function right here just undoes that negative logarithm that we did in the previous slide. And similarly, we can relate these two. So H3O plus times OH minus is 10 to the minus 14th. Right, so we said that pH plus pOH is 14. H3O plus times OH minus is 10 to the minus 14th. This number right here, by the way, 10 to the minus 14th, has a very important name. This number is actually called Kw. This is what's called the equilibrium constant of water. Right, so at 25 degrees, water has an equilibrium constant of 10 to the minus 14th. So I've just given you guys 6 different equations to work with. So what we can do in theory is I'm going to say H3O plus, OH minus, pH, and pOH. Right, so we can convert, if I know one of these 4 things, we can convert between the other 3. Right, so we'll start off with the easy one, pH and H3O plus. If I know the concentration of H3O plus, I can find the pH by doing negative log of H3O plus. If I know the pH, I can work backwards to find H3O plus by doing 10 to the minus pH. Similarly, I can go from OH minus to pOH by doing negative log of hydroxide, or go from pOH to hydroxide concentration by doing my inverse log, so 10 to the minus pOH. pH and pOH convert directly into each other, right? So pH plus pOH equals 14. And H3O plus and OH minus convert directly into each other. Right, so we can say that H3O plus times OH minus equals 10 to the minus 14th. Right, so this little box right here, if you know one of those 4 things, you can use all these equations to find the other 4, or find the other 3. And just put the little negative sign in there to be technically correct. Right, so these are the equations that you're going to need to use, and this is how you're going to need to use them. I'll give you one, and you have to find at least one of the others. Right, so let's try a couple of examples with this. So first example, I have nitric acid solution, and it has a concentration of 0.032 molar. Now, in order to find the pH of this, I'm going to do my negative log. All right, so pH is equal to negative log of H3O plus. H3O plus in this case is just the concentration of the acid, right? So that's going to equal negative log 0.032, which will give us a pH of 1.49. All right, so this is a fairly acidic substance. Nitric acid is a strong acid. It's fairly acidic, pH of 1.49. Now let's try a different example here. Now I want to calculate the pH of a 0.55 molar methylamine solution. Now one thing I will usually point out to you, in this case methylamine, it's useful to know that methylamine is actually a base. Most amines are bases. Now, at the end, I have a little sentence here. It says, assume a 7.2% dissociation. What this means right here, this means that the actual hydroxide concentration is 7.2% of the initial concentration. Right, so out of this 0.55 molar, because methylamine is a weak base, it's not one of our strong bases, right? It's not a group 1 or group 2 hydroxide. So it only breaks up a little bit. In fact, only 7.2% of it breaks up. Right, so we're going to do 7.2% of 0.55. So first thing I have to do is I'm going to do 7.2% of 0.55 molar. Right, so 0.072 times 0.55 gives me 0.0396 molar. That is the concentration of hydroxide in this solution. Right, so now my pOH is negative log of hydroxide. Because I'm working with a base, it's just negative log of this number. That's actually negative log of, which equals negative log 0.0396. And that gives me a pOH of 1.40. So again, this is still fairly basic, right? pOH of 1.4. The lower the pH, the more acidic it is. The lower the pOH, the more basic it is. Now you guys should already know that for a solution at 25 degrees, below 7 is acidic, above 7 is basic. Right, we're always going to be working at 25 degrees here, so you don't have to really worry about anything different than that. Now let's try a third example of this. So this is, I'm going to ask you for everything based off of one number. Right, so I'm asking you for all 4 of these based off of my initial concentration. So I have 0.098 molar HI. So what that immediately tells me, HI is an acid. So that will immediately tell me that H3O plus is 0.0098 molar. I know that because it's given to me here, and there's no information about how much it breaks up, because HI is a strong acid, it breaks up entirely. If I gave you a weak acid, you'd have to do some multiplication first. Right, so there's our H3O plus. From there, we have a couple of different options. We can either go from H3O plus to OH minus, then the pOH, then the pH, or we can do pH first. I'm usually a fan of doing the easier calculations, so my next calculation will be pH. pH is equal to negative log of H3O plus, so negative log 0.0098, which gives me 2.01. Right, so the pH of this solution of this hydroiodic acid is 2.01, so again, fairly acidic. Once I know that, I can find pOH. pOH Now, again, I can do it using OH minus concentration, or I know that pH plus pOH equals 14, right? So I remember that pH plus pOH is 14. So I'm going to get 14 minus pH. All right, so 14 minus 2.01 is 11.99. So that's my pOH. Then finally, I can find my hydroxide concentration. Again, I have two ways I can do this. I can either, for my hydroxide concentration, do H3O plus times OH minus equals 10 to the minus 14th, or I can say that OH minus is 10 to the negative pOH. I have the information to solve for both of these. The one that's easier is going to be this second one right here because I don't have to worry about doing that much of scientific notation. Right, so this is going to be 10 to the negative 11.99. Now, please do me a favor and don't be lazy. I want you to give me an actual numerical answer to this. Don't leave it in exponential form. All right, so if I do 10 raised to the negative 11.99, that gives me a scientific notation answer of 1.02 times 10 to the minus 12. And since this is a concentration, this will be molar. So these four right here are my answers to this question. Again, if you have any questions as to how the math works, please feel free to contact me through email at any point in time this week. I will get back to you during normal school hours.